Okay, let's take a look at this question. Here you have a buffer that is made out of a weak base, that is NH3, and a salt of the weak base, which is NH4Cl. So when you dissolve this salt NH4Cl into water, it will dissociate to give you NH4 plus and Cl minus. So I hope that you recognize NH4 plus is the conjugate acid of NH3. Okay, before we even start, let me just write out the base dissociation reaction for NH3. Alright, so I hope you can see this, that NH3 is the weak base and NH4 plus is actually the conjugate acid for NH3. So here you are asked to calculate the pH, and for buffer solutions, you can use the Henderson-Hasselbalch equation to calculate pH. So pH equals to pKa plus log conjugate base. In this case, the base would be NH3 divided by the conjugate acid, which in this case, it is NH4. So when you add HCl to the buffer solution, a reaction is going to take place. Since you are adding excess acid, okay, because HCl would give you H plus, it will completely dissociate to give you H plus since it is a strong acid. Okay, so H plus will undergo an acid-base reaction. So since you are adding acid, then the base will be reacting with the acid. So in this buffer solution, you have NH3 and you have NH4 plus. One is a base, one is an acid. So the base, which is NH3, is going to react with the acid. So let's write out the equation that happens. NH3 is going to react with H plus to form NH4 plus. Okay, so notice in this equation, I write an irreversible arrow because here H plus comes from HCl, which is a strong acid. In any acid-base reaction, as long as there is a strong acid or a strong base, the reaction is going to proceed to completion. So it will be an irreversible reaction. Now, we want to find out the new concentrations of NH3 and NH4 plus after they have reacted with the acid. But instead of calculating concentrations, we will calculate in number of moles. And this is because when you are mixing the solutions, the mixing of solutions causes a change in concentrations because you are changing the volume. And also, the reaction itself will also change the concentration. So it's going to be very complicated if you try to calculate concentration. So it's actually easier to calculate number of moles. So let's find out the initial number of moles of NH3 and NH4 plus in the buffer solution before you add HCl. For NH3, the concentration is given as 0.2 molar. The volume of the buffer is 65 ml. So number of moles is actually concentration times volume. So that's 0.2 times 65 ml. And you will get 0.013 moles. So similarly for NH4 plus, the initial concentration is 0.20 and the volume of buffer solution is 65 ml. So initial number of moles is also 0.013 moles. Now let's look at the change, which is the number of moles of H plus that were added to the solution. So for H plus, the concentration of HCl is 0.1 molar and the volume is 25 ml. So we get 0.0025 moles that were added into the solution. This is going to be an irreversible reaction. So by looking at mole ratio, we can calculate the new amounts of NH3 and NH4+. NH3 reacts with H plus in a 1:1 mole ratio. So you can calculate the amount of NH3 by taking the initial number of moles and minusing the number of moles that react with H plus. So that's initial number of moles. Amount of moles that reacts is going to be 0.0025 because it reacts with H plus in a 1:1 mole ratio. So here we have 0.0105 moles. As for NH4+, there will be more NH4+ being formed. So the number of moles is going to increase. You have initial 0.013 moles and you are going to add an additional 0.0025 moles that are being formed from this reaction. Okay, so now you have the new number of moles for NH3 and NH4+, and you can now use these values in the Henderson-Hasselbalch equation. So again, the equation is pH equals pKa plus log of ammonia concentration divided by NH4 concentration, NH4+. So you don't have pKa, but you are given Ka. So pKa will be negative log Ka. And you have calculated the number of moles. So to get concentration, you just take moles divide by the volume. For NH3, the number of moles divide by volume. So volume is now 25 ml plus 65 ml, so that's 90 ml. And similarly for NH4+, you have number of moles divide by the volume, which is 90 ml. Okay, now you have your final answer, which is pH 9.08. This is slightly different from the McGraw-Hill answer because for their answer, they did some rounding in their intermediate steps, whereas for me, I left the rounding to the last step to do.